Hello, this is Miss Goodwin, and I forgot my headphones, so you're gonna have to bear with me if this sounds a little funny. But today we are covering the rules of exponents. So the objective for today is that we can rewrite expressions involving rational exponents using the properties of exponents. If you were here on February 22nd, we did start this, but I'm gonna cover all of it in the video. So to begin, let's look at some vocabulary. A monomial is a number, variable, or a product of a number and one or more variables. Some examples are 34xy and 7a squared b. So one key thing for monomials is there is no plus sign or minus sign. Okay? That's how you know it's a monomial. Our next variable or our next vocabulary is power. So we're going to be working with exponents, which are forms of repeated multiplication. Okay. So here we have the example 5 to the second power. 5 is going to be the base. That is what is being multiplied. And the exponent, which is this little number on top, also known as the index, is how many times we multiply. Let's get started. So rules of exponents. The first one we got is product of powers. The example here is a to the m times a to the n equals a to the m plus n. So the product of powers rule says that if multiplying two numbers with the same base, we add the exponents. We look here at the first example, we get 5 to the second power times 5 to the sixth power. This is the same as 5 to the 2 plus 6 power, which is 5 to the 8th power. Okay, that's it. That's a big number. It's like 39,625. So I want to remind you, this is not the same as 5 times 8. It is 5 times 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 5. A lot of fives. Okay? But that's it. That's the product of power rules. Let's look at this next example. We have y to the fourth times y to the third times y. There is an invisible 1. So we're going to do the same thing. Our base is y. That is raised to the 4 plus 3 plus 1, which is y to the 8th. Okay. Let's look at the next one. Now, this time we have a bigger monomial. There's both coefficients and variables. So we're going to tackle each piece of that separately. So we get the 7 times 6. And the y to the 5th times y. Now this works because multiplication is commutative. You can rearrange anything in a multiplication problem. So 7 times 6 is 42. And y to the 5th times y to that invisible 1 again is y to the 5 plus 1. Simplify that, we get 42 y to the 6th. And we are done. That 6 does not affect the 42. It only affects the y. Let's look at another example here. We have negative 3x to the second power y to the 7th times 5x y to the 6th. So first, let's tackle our coefficients. That's negative 3 times 5, which is negative 15. I'm just going to write it here. Then we're going to tackle our x's, which is x to the second times x, which is x to the 2 plus 1, which is x to the third. And last but not least, we have y to the 7th and y to the 6th, which is the same as y to the 7 plus 6, which is y to the 13th. And we are done. Okay. Let's move on to the next one. We got the quotient of powers rule. So this time we are dividing. So in the example here, we have a to the m divided by a to the n equals a to the m minus n. So if we are dividing two numbers with the same base, we are going to subtract. So for example, here we have y to the 6 over y. That is going to give me y to the 6 minus 1. There's an invisible 1. And we're going to take that smaller exponent to the bigger exponent. So 6 minus 1 is 5, so we're left with y to the 5th power. Now we do the same thing with numbers. So I'm going to take that 2. You get 6 to the 13 minus 2, which is 6 to the 11th. And we're done. Now here we have multiple pieces to each monomial this time. So let's tackle them separately. 10 over 15 is the same as 2 over 3. And I'm going to write that again. Now a to the 7th over a to the 5th. That's going to be a to the 7th and minus 5. Which is the same as a to the 2nd power. And these are all on top. Now lastly, we have b to the 9 minus 9, which gives us b to the 0. And that's going to be 1. We'll see why in a few moments. So we don't have to write that here because it's just times 1. And we don't have to write times 1. So we get 2a squared over 3 as our final answer. And we're done with that. Let's go ahead and look at the next one. And now we got our 0 exponent. So any non-zero number with an exponent of 0 is equal to 1. So let's explore. There's a couple ways we could look at this. So I have 8 to the 2nd over 8 to the 2nd. Let's subtract 2 there. And that gives us 8 to the 0. Technically over 8 to the 0 as well. Yes. But now let's solve this a different way. Let's say we get 8 to the 2nd power is equal to 64. So this fraction is 64 over 64, which is just equal to 1. So anytime we are dividing, or anytime we have a number to the 0 power, it's basically dividing by itself, which makes it 1. So 8 to the 0 power is 1. Okay. Whoopsies. Now let's look at this problem down here. This time we have a binomial in parentheses, all raised to the 0 power. Easily enough, that is literally just equal to 1 because this whole piece is raised to the 0 power. And we know that because the parentheses are grouping that together. Let's look at the next problem. We have 8x to the 0 plus 5. Now, you're probably thinking this is going to be 1 plus 5, which is 6. That is not the case. The 0 is only on the x. We don't have any parentheses grouping the 8 and x together. So only that x becomes 1. So we get 8 times 1 plus 5, which is 8. Add that to 5, we get 13. And we are done. Okay. Let's look at negative exponent. A to the negative n equals 1 over a to the n. So for any non-zero number a raised to a negative exponent, place the power in the denominator to rewrite the power with a positive exponent. So if you recall what I said earlier when we were working with the quotient of a power rule, you might remember I said bring the smaller number to the bigger number. So if we only took it to the top, so let's bring that 5 up, we get b to the 2 minus 5, which is b to the negative 3. Or we could solve it by bringing the 2 down. So we get 1 over b to the 5 minus 2. That 1 is a placeholder, so we know that we're going to the denominator. And that's 1 over b to the 3rd power. So both of these are equal to each other. So b to the negative 3 is equal to 1 over b to the 3rd. So if we look at these examples here, we have 2 to the negative 3. This is the same as 1 over 2 to the 3rd power. And now same here, we have parentheses, so that whole piece is going to be brought down below the denominator, in the denominator. So this is 1 over negative 3 parentheses to the 3rd. Now, a common mistake I see here, when folks would bring down the power, they would turn this to a positive. It does not turn into a positive. That negative 3 in the exponent is the only thing that changes signs. Okay? So be careful with that. Okay? Now, let's say I'm going to write another example down here. We have 2a to the negative 3. I want to show you this one because this negative 3 is only on the a. So that's the only one that's going to be bumped down. So the 2 is going to stay in the numerator, and that a to the 3rd is going to come down. Okay? All right. We got a couple more rules. We got power of a power. So if raising a power to a power, multiply the exponents. So this time we have an exponent raised to another exponent. So for the first example, we have x to the 2nd power raised to the 8th power. So this is x to the 2 times 8, which is x to the 16th. And we're done. We're done with that. On this one, we have y to the negative 3 times negative 4. So we had y to the negative 3rd raised to the negative 4th. So we're going to multiply the negative 3 and negative 4, which gives us y to the 12th. And we're done there. Nothing more we can do. We don't know what x or y are, so we can't simplify these further. Okay, 2 more. Power of a product. We have a, b multiplied together, all raised to the m power. This equals a to the m times b to the m. We want to find the power of each factor in the parentheses and multiply those. So when you have a monomial inside the parentheses, you can essentially distribute that exponent to each term inside. Now does not apply to binomials. This is only for monomials. So this 3 is going to go here and here and here and here. So we had 4x to the third y z all raised to the third power. So we're going to get 4 to the third times x to the third raised to the third times y to the third times z to the third. This can be simplified. 4 to the third is 64. X to the third is x to the ninth. Y to the third, z to the third. And that is our final answer. This works with negatives as well. So we have 7xy to the negative 2, all raised to the negative 2. So we get 7 to negative 2, x to the negative 2, parentheses, y to the negative 2, all raised to the negative 2. Now, this I know is going to become positive exponent, but since both of these are negative, we're going to bring them down. So we're going to have a fraction, y negative 2 to the negative 2 power is y to the fourth. And on the bottom, we get 7 squared x squared, which is the same as y to the fourth, 49x over 49x squared. And you're done. I know that one was a little tricky. Okay. And the last one for this one, we get 6x to the negative 6, y to the negative 7, z to the 0. So give that exponent to everything. Okay. 6 to the negative 2, I know that goes below the fraction. It's going to be 6 squared. On top, we get 6, or x to the negative 6 times raised to the negative 2. That becomes x to the 12th. Y to negative 7 to the negative 2 is y to the 14th. And z to the 0 to negative 2, that is just going to be 0, which gives us a 1. So we're done with that. Okay. So this is our final answer. Well, let's simplify that bottom piece. We get x to the 12th, y to the 14th over 36, and we're done. Okay. Okay. Last one, we got power of a quotient. This is essentially saying the same thing, but this time we have a quotient or a fraction, whatever you want to call it. A over b all raised to the m, everything gets that m. So for any numbers a and b where b is not equal to 0, if the quotient of a and b is raised to a power, raise both the numerator and denominator to the given power. So, for example, here we have 3 over 5, all raised to the second power. This is 3 to the second power over 5 to the second power, which is 9 over 25. Okay. Now here we do the same thing. We get 2a to the 5th over b to the 7th raised to the second power. So we're going to get 2a to the 5th. All raised to the second power over b to the 7th to the second power. This becomes 2 to the second power, a to the 5 times 2 over b to the 7 times 2, which gives us 4a to the 10th, b to the over b to the 14th. Okay. Last two, we got a 3 here. Everything is going to get that 3. It becomes 27. A to the negative 12 over b to the 21st. This a term is going to come down. We get 27 over a to the 12th, b to the 21st. Okay. Last one. Okay, we have a negative here. So everything's going to get that -6. So we get a to the -2, b to the -5th, over c to the -11th. That's raised to the -6 power. So that becomes a to the -2 raised to the -6. b to the -5 to the -6. c to the -11 to the -6. Okay. Multiply that, and the negatives are going to cancel out. So a to the -2 raised to the -6 becomes a to the 12th. The b term, -5 times -6, gives us just +30. -11 times -6 is 66. So we get c to the 66. And that is all we can do. So thank you for bearing with me.